Good morning everybody, e buongiorno a tutti, benvenuti alla seconda giornata del programma di questa EMA Digital Terrace. Il programma prevedeva un incontro inizialmente in lingua italiana, ma abbiamo tanti stranieri, quindi abbiamo deciso di switchare in lingua inglese in modo che possa essere fruibile da tutto il pubblico. Però volevo dire due parole su questa giornata perché abbiamo un programma di incontri molto fitto, parliamo di intelligenza artificiale, parliamo di robotica, parliamo di cyber security, parliamo di dati, quindi un programma che ci porterà fino a sera, quindi mi raccomando andate a vederlo su emadigital.it. Non indugiamo oltre, so I'd like to introduce the first event of today. We are talking about artificial intelligence and the perspective for the manufacturers. We are doing that with our speakers today. I'm very happy to welcome Francesca Possenti-Hennig, which is the leader of the Cema Project Team 11 dealing with artificial intelligence and working for John Deere. Thank you, Francesca, for being here. Welcome to Luca Ferrari, an expert of Cema PT11 from CNH. Thank you, Luca, for being here as well. Marco Bertogna from University of Modena Reggio Emilia and Hyperlab will be hopefully reaching us later because of traffic jam. And Giampaolo Barbieri, who is Technical Director, owner of Barbieri SRL. Providing a perspective from a small medium enterprise on artificial intelligence. I'd like, after that, to introduce our first speaker, Francesca, to reach me on the stage. I give you the floor for your presentation, talking a little bit about what the data AI means for our industry and what burdens of perspective are we facing up.
Thank you very much, and thank you for having me today. The presentation has been conceived in Italian, but the slides are in English. So when we start to talk about the AI, I'm looking if I can continue to switch. Maybe in that. Here it is. So when you're talking about AI, there is a lot of discussion about what artificial intelligence is in the first place. And the differentiation between automation and autonomy is still a huge dispute among the experts, particularly because you have some machine learning systems that might qualify as artificial intelligence under the definition of the AI Act. However, they actually are not artificial intelligence if you look at them from a technical point of view. In this sense, I'm providing you the definition that was provided by the AI regulation and compare the definition to the Biden executive order. What you can see is that the European one is more descriptive and the American one is more a dynamic definition. But basically, the main element is the fact that it is a system with varying level of autonomy that it's capable to understand from inputs and data. All the other characteristics, like its adaptiveness or the possibility to influence the physical world, are optional. So they might be, but they are not a characteristic of artificial intelligence. What opens up the definition to a very broad spectrum of application. On the other hand, the artificial intelligence definition in Biden executive order is more based about the understanding. So the basic concepts are similar. The difference that we have in the two countries or the two jurisdictions is that while with the AI regulation, we're trying in Europe to set a horizontal regulation that doesn't work just for machinery, but all kind of products, all kind of services, all kind of application. In the US, the approach is more to have a sectorial application. So that means they are looking, the agencies are looking from a sectorial point of view or from a recipient, a customer point of view, in order to understand what needs to be done in respect of a regulation. Of course, the difference is also given by our system, as Europe has a system that it provides a compliant regulation. So for the one who wants to understand how this works, we have the AI regulation are ex ante regulation. So that means they are applicable despite any accident. So there is no need of an accident to happen. You need to fulfill the regulation for placing your product on the market. So you cannot place, or you might incur in penalties if the products do not fulfill the requirement. And this is the difference between the AI Act, so the AI regulation, towards the AI Liability Act, that it's still under discussion at the EU level, so it has not published yet. There is a huge discussion with Cema about how we can influence this regulation. And this is the part that it's related to the liability. So that means when an accident happens, this is how the liability will be assigned. Small spoiler, it looks like we're going towards strict liability, and this is the task that Alessio, Luca, myself, and the PT11 at Cema has, is to try to provide a possibility for the companies to defend themselves. The difference to the US is that the US system provides some rules, but the objective of the rule that we have in the regulation, like dissuading companies to bring products on the market that can be dangerous, is this protection that we have in regulation is provided ex post in the US through the punitive damages. So they have a similar objective, but a different way of application. I'm providing here, so for the expert of artificial intelligence, this is a very high level that I put here to discuss what do you need to take into account when you're programming your artificial intelligence, given the requirement in the new regulation. So basically, when you define your goals in the future, you need to document how do you assess the goal. So how do you assess that artificial intelligence is better than, for example, a mathematical model in order to achieve a goal? And you need to document that. You need also to provide how do you set your assumptions. So what are the reasonable or the rationale for your assumption? And those are requirements that I'm not putting here for you. Those are the requirements of the AI Act. So they're a regulatory requirement that you need to fulfill. Furthermore, when you start to do your collection, your data collection processes, you need on one side to take into account not only the AI Act, but also the additional regulation that you have in the European Union. So if you're collecting data that could contain individual or personal information, you might have also to apply the GDPR. If you have machinery data, you need to make sure that those data have been accessed properly. For example, if they're covered by IP, you have to check also if you can access those data. When you're doing your fine-tuning and setting your hyperparameters, you need to explain why you chose those parameters, why you chose those techniques. But it's not that easy as it seems in the AI Act, because it's written here. You have just to show or just to write this down. But it's not that easy because a lot of the decisions are taken by the developer on the basis of their experience, on the basis of what they think is reasonable. How do you part your data set in order to have to create your validation set? It's about your experience. So what the AI Act provides you is they're not at this point of time giving you indication of how many data points do you need to show, but the Act requires you to provide the rationale why you chose to have a validation set of X number of data. Why do you chose a specific model? Why do you chose a specific parameter? And the same in this sense. sorry. In this sense, this is an operation that you need to do not just once, but every time you reevaluate your AI assessment, you refine and you add. Well, this is more for the lawyers. It was to provide an indication how the development started. So if you're interested to get this image, I can refer you to Attention is All You Need, that it's a paper published by Google. So this is the picture of that, and this is intended just to provide the information. Well, we're in a huge transformation phase also in artificial intelligence, as we are seeing more and more the transformer model taking over. If you're interested how those models will integrate with the machine learning, well, this is an example. It's not the only example, but this is one of the examples that the MIT has published recently. This is just to show how much new technologies are integrating the way we use to program artificial intelligence. And this makes a huge difference for the application of the AI Act, because if you can basically provide some description or the way you decided the different the collection of the data, the way you chose your model, the way you set your hyperparameters. Now, if you integrate pre-trained models in your systems, it might be more difficult to prove that, because you just don't know. If you're licensing a model from Llama, for example, or from Copilot or whatever other providers you have, you might not have access to those information in order to fulfill the requirement of the AI Act. So we have also new risks in the value chain that are coming up. In the past, we had, as said, just, well, our product, our development, our engineers, our developers. Now we have a chain of risk. So we have cloud providers. We might have new foundation models that are integrated. We might also have risk related to different adaptation and optimization, so fine-tuning that it's provided for our specific industry. So the complexity of the system is increasing and the dependency are increasing. But the AI regulation, as said, was drafted in a time where attention is all you need was not an issue. So that's the reason why it provided descriptions that you might find difficult to apply today. To give a basic understanding of the AI regulation, it provides technology risk allocation. So what you have are different categories of artificial intelligence. Some are prohibited, some are considered high risk. The new foundational models are considered to be going to be applied differently depending if they are embedded in systems that might fall under high risk. And regular artificial intelligence is everything that you have from the app on your phone to make your night look nicer when you have your Teams conference, or to catch the best music station. What is important about prohibited artificial intelligence is that as the regulation has come into force in 1st of August 2021, those prohibition will enter into force after 6 months. So we're pretty close to the time where our prohibited artificial intelligence will be sanctioned. So when you're looking about, this is a summary. If you want to get all the prohibited artificial intelligence, you might look at Article 5 of the regulation. Most of you might say, well, I'm producing systems, I will not, probably not have artificial intelligence in my systems. But if you're reading Article 5, there are still a lot of questions. Like if you take subliminal influences of consciousness consciousness in order to make you take a decision that you otherwise wouldn't have taken. Well, is it not the case of advertising in the first place? So where an artificial intelligence starts to become prohibited? When it goes to sentiment analysis, one of my colleagues at the university started to program a system that scrapes the internet in order to picture people with different face emotions, and for the objective to create a transformer system that recognizes your expression, your voice, or your body language in order to say, well, is this person angry? Is this person happy? Is this person assertive? I mean, this falls, if you use it in your workplace, falls under prohibited AI. And if you use it in your business activities, this might be high risk. So this is the kind, it's just an example, this is the kind of artificial intelligence that the EU thinks, or that the EU consider to go against the ethical understanding of what is, or what artificial intelligence should do. But the ethical understanding is the European one. So it's not identical to the ethical understanding in different jurisdictions in different countries. So this sentiment analysis is pretty fine in the US, even if you use it, for example, and this is the goal of the project, even if you use it to assess a jury that will take a decision for a case. So using that, it's ethically possible, at least. There is a discussion ongoing, but this is an example of how this might have an influence. On the high risk, well, the definition of high risk is very diverse. So you might have a definition in countries like the US that it's more related on what kind of machine you use, where do you use it. In Europe, we have a pretty closed shop list in Annex 3, where you have the targeted infrastructure, you have the activities, and then you have a chained legislation when it comes to Article 6, to the definition of what is high risk in, for example, machinery. It refers basically to the legislation covered in the Annex 1 that provides, for example, the link to the machinery regulation, and then it provides an additional requirement saying, well, if the AI is intended to be used as a safety component, and here, please, I see that I missed to change annex. It's Annex 1. And if you are required to undergo a third-party assessment, then your system is considered to be high risk. If you look into the machinery regulation, however, the definition of what is subject to undergo a third-party assessment, it's not so clear. So it's still under discussion. For the classification of high risk asset, as we described this further, when you do the sentiment analysis outside of the environment work or education environment, then you have potentially a high risk system. Or if you're doing your personals or your employee selection using AI, this might fall under high risk systems. And if you're under a high-risk system, you have to fulfill the requirements that are basically to have a risk management system, to have a technical documentation, to provide transparency. And here also the understanding of transparency in the US and in Europe are pretty different. While we have the description of the system, so the model, the data you collected, the assumption and everything in the data governance, the US understands this as transparency. So this is the difference that you might have. To give you an example how deep this goes, it requires you to provide extremely detailed information about your data collection, did you prepared, how did you work on your data. For example, if you use your data or if you augmented your data, you need to provide the reasonable and what you did. What is particularly interesting is also that the AI regulation provides also obligation for importers. So if you're importing an AI system in Europe, you might be required to provide those certification. And I'm jumping a little bit because I see that we could speak about that for hours. What it's particularly interesting is that you're not only, as a dealer, are obliged to provide the certification. If you spot that your artificial intelligence might be considered potentially risky, you have to take it out of the market. So this is a pretty high responsibility for the dealer and for the operators. That means for the user, for the farmer that uses artificial intelligence, for the companies that use artificial intelligence internally, you need to provide those or you need to have the human supervision on how you use artificial intelligence, but you have a lot of different requirements that you need to fulfill just to perform the AI or just to perform the activities. This is just a fast overview, and I would now give back the information. I know that this is a discussion that could at least last for an hour, but in this case, I would let now the next speaker. And if you have any question, please do not hesitate to contact me.
Thank you, Francesca, for this overview. It would take hours to speak about the AA Act, AA product liability. We started hard with all the burdens or obligations for manufacturers, but now we try to maybe look to the expectations of manufacturers and to the trends of the industry. So please, Luca, reach me on the stage. I give you the floor for presenting the insight and expectation on that area.
Okay. Thanks, Alessio, for the introduction, and thanks for the invitation. So as I said, I'm Luca Ferrari from CNH, and today the goal is just to give you a bit of industry perspective on AI with some future trends and expectation. So my plan would be really to provide a bit a general overview of where we are, highlighting some of the main challenges that are, let me say, that we see to go into a production of the AI system, and finally giving a bit an overview of the system that we already have in production. I mean, I will go very fast in this slide. I mean, everybody knows that AI is everywhere. Probably, I mean, as Francesca was saying, based on the AI definition, now lots of common software are becoming really AI. But there are already a lot of applications like for machine vision, robotics, deep learnings, and these are really, let me say, impacting a lot of different sectors and industries like automotive, education, also the agriculture, but I mean, they are, let me say, everywhere. As CNH, but I would say not only CNH, I think that we are really becoming part of the farm ecosystem with our customer. We see some, I would say, three main levels, and I think that there are also trend and expectation for all of these levels. For sure, there is, let me say, a bottom layer that is the physical layer that is really fundamental. Our machine, but not only our machine, are becoming really sort of data collector. So we have sensor on our machine, we have sensor in the field. There are information that are coming, for example, from energy management system, from the livestock. So this is really the fundamental layer. Then we have a second layer that is the edge layer that is becoming for sure more and more important. We always now hear about edge AI or AI on the edge, because one of the challenges is that AI is really driven by data, but moving the data is a complex task. So the fact that we have more and more data from, for example, from our machine, and at the same time, probably the professor will explain later, but we have also new neural accelerator that are also capable of managing this data at the edge, allow us already to get insights already on the machine and reduce the amount of data that we need to move. Finally, let me say there is the cloud layer. So really the cloud that everybody knows, where we have like our FMAIS system the farm management information system, where all this data can be grouped, can be integrated also with third party and apply analytics, machine learning, deep learning algorithms. We should not forget that for sure is a big enabler, the network layer. So really, I think is this one. I mean, to enable AI, there is also fundamental to have the infrastructure to move the data, the infrastructure to store them in a way that then can be scalable, but also, let me say, the infrastructure to store them in a way that then can be reused. I will, as I said, try to go through a high level, but the main challenges that we see to bring this to production. For sure, let me say, I think this is a simplified version of also what Francesca presented before, but I would like to say that there are, we see three main pillars. I know there could be a lot more, but for sure, as we said, data is fundamental. So data, and especially how we curate the data. So we need high quality, well labeled, well annotated data that should be representative of the use case that we want to solve. Now there is this, let me say, GIGO acronym, so garbage in, garbage out. So if you don't have good data, you will have bad results. Secondly, we need to put in place, as also Francesca was saying, showing before, a sort of architecture that allow us to manage how we develop the algorithm. It is called machine learning operation. So we need to version now not only the software, but also the data, which data we use for which training, how they are annotated, and this is becoming fundamental really to bring it to production. And finally, I mean, I will not spend many words on regulation. I think that it was really clear how this really can affect the journey to bring this model to production. So going a bit, okay, so I mean, just to give a bit more details without spending too many words, but about the importance of data, I mean, I think that this plot, that is not mine, you can see the source below, but clearly show in a typical machine learning project how much time is spent really on the data, getting data, cleaning them, annotating them and so on. If you make the sum, it's more or less 80%. So working on the data curation is really important to try to reduce cost and at the same time also have more accurate machine learning models. So for sure there is, let me say, a trend to try also to work on data that, so to try also to have more variety on the data to prevent the overfitting. Obviously, I mean, we know our environment is not easy. There are a lot of challenges, so getting good data is really challenging. We have a lot of like dust, fog, rain, we have vibration, we have a lot of different lighting conditions, so it's not a control environment. So for sure we see a big trend also on the synthetic data. Synthetic data have a lot of, let me say, advantages. They can overcome the data scarcity. I can create conditions that are not always easy to have in the field, or maybe they are not so usual. They can prevent some issue related to privacy and security. For sure they can have a cost effectiveness. So I mean, I can save money in collecting them, annotating them, and we can also prevent some bias mitigation. Here is just an example of a thesis that we did with the University of Modena, where we were, for example, doing some, let me say, generation of synthetic data. I will not spend too much time on the MLOps part, as I said before, but for sure this is becoming fundamental in every AI development, at least to bring it to production, because it allows us really to try to monitor and version all the development and also being able to better understand the quality of the model and how we reach those quality and how we can improve it. Finally, let me say, I will not spend too much time on AI regulation. I think that it was well and deeply discussed before, but this is a fundamental pillar that is impacting also our development. Going a bit on the application, for sure, let me say, AI is now everywhere. We have already some application in production. So for sure there are applications of AI for, we call it automation. So we can automate some of the system and of our machine. Like on our combine harvester, we have a system that is called IntelliSense that is capable to detect the quality of the grain, the presence of impurities. And also in the last year 11 that was launched at Agritechnica last year, we have also a system based on radar that is called IntelliSpread that is capable to measure how the spreading is performed and to compensate. For example, if you have lateral wind, you will not have an even spread of the crop, of the residue on the soil. So based on this system, you can make it more, let me say, more even. So really system that can be used to improve the efficiency and the productivity of our machine and to help our customer. For sure, we see application on guidance. I mean, we won the, let me say, the EMA Technical Innovation Award with an assisted system for guidance for specialty tractor. And we also presented, let me say, at Agritechnica last, I think 3 years ago, we won a medal for the IntelliBale system, where we have a LiDAR sensor that is capable to detect the SWOT, to perform a SWOT guidance, and also to estimate the volume of the SWOT to regulate through isobus the speed of the tractor. And then, I mean, we bought Raven in the past years, and through this acquisition, we have also some application based on guidance. For example, the so-called VSN, that is a vision system that is used to drive the sprayer to correct and nudge the GPS position based on the real position of the row crop. And finally, let me say the OmniCart, that is also a product that we got from Raven. Finally, for sure there are lots of other applications, but just a few other examples is, let me call precision application. I think that we have a booth here on digital part, so everybody can see, let me say, how many applications we can release on this part. Precision application, just a few examples. So we bought Augmenta, so it has a sort of multispectral sensor and some algorithm that, for example, can regulate, can enable a variable rate application based on the real-time sense of the nitrogen content of the plant. We also had a small investment in Stout, that is just another example of AI. They have a mechanical weeder, so they are capable of really detecting the winds and operating the weeding. Going to the end, I mean, these are just few use cases applied to our machine. As you can imagine, and you can see probably also in your business, AI is also applying a lot of other areas. So this is just another example. It's a funded project on manufacturing. And the idea was really to apply AI for predictive maintenance, but also related to what Francesca was presenting before. Here there was also the idea to try to work on the explainable AI. So as we have been asked, let me say, it is asked to try to explain what AI is doing. Part of the project was really also to try to work and try to make an AI that could be also explainable. So to explain what it is doing. This is just additional details that I will miss. Just to conclude, I mean, I think that for sure, let me say, there is a lot of possibilities by fusing, let me say, our capabilities with what AI can bring. There is a lot of challenges that I try a bit to highlight, and for sure regulation, as shown before, is a fundamental one. I think that there is also, let me say, a challenge on talents, because there is a shift. I would say in the past, the value was generated by the mechanics, supported by electronics, software, and data, and we are really moving towards an era where the value is generated by the electronics, the software, and the data, supported by the mechanics. And this for sure is a challenge, but I think also an opportunity for a lot of also new generation.
Thank you. Thank you, Luca. I'm sorry for moving fast in this. We changed a little bit the order of presentation just to keep things agile, and so I'd like to give the floor to Giampaolo Barbieri. because we learned about, you know, the burdens, we learned about the expectation. There's a lot of investment in that area, but how medium and small enterprises see values in investing in artificial intelligence areas? Please.
Okay. So, mi dai il cosino? Good morning to everybody. I am Giampaolo Barbieri, CEO of our company producing smart farming machine, especially for the crops in rows, let's say, okay, horticulture and orchard, okay. I make a very simple presentations, half in English, half in Italian, because was not clear how it was held the speech. So in order not to make a mistake, I mix the both. Okay. So the target of my presentation is to give a message that the artificial intelligent tools are something that is affordable for every small and medium enterprise. So it's not something that is high targeting, but is a big challenge and a big opportunity to every company, okay? Okay. So we consider the artificial intelligence as a big wave, okay? Similarly to internet is required to have a change of the mind, a new approach, okay? We have two possibilities: or we surf the wave or we dive, okay? So what the effect of artificial intelligence tools have in the small company is disruptive, okay? Disruptive for two reasons. The first is the speed how this technology is developing, and also the efficiency of the tool to perform some task, okay? These two effects make the expanding the use of the artificial intelligence tools in a disruptive way. It's not possible for a small, medium enterprise to have an approach, wait and see. We look at what the competitors are doing, okay? Because in this case, we are already losing our competitiveness, okay? So we use these tools for increase the efficiency of all the operation of the machine we are and the type of the operation that our machine that we produce is doing. It's very important to support the decision, because what it happens is that the availability of data for all new agriculture machinery, they are collecting pictures, they are collecting the climate condition, they are collecting many data. So the capability to manage this data give us a very good support to take a decision to improve the technology of the cultivation and the approach of our job, let's say. I was looking for some research, and I found this one that was made in United States. This study made on some thousands of small enterprises try to find a relations between the probability of revenue increase and the probability of workforce growth in a small company. And they found correlations that related to the number of digital tools based on artificial intelligence that are used by the company. They found that the revenue is, the probability to increase the revenue is double for companies that use at least 8 different tools based on artificial intelligence, okay? And the probability of workforce growth for those companies is 3 times bigger, so the company develop much faster if they are using 8 digital tools instead of 3 digital tools, okay? They found this correlation, and it's important to have this idea in order to try to catch this chance. Okay, this is very common. Everybody that are here know how is developing, how fast is developing the investment and the business of artificial intelligence, because every day we found new tools on our telephone, on our internet. This is made by Politecnico di Milano. I think it's Italian. Okay. The result of the study is that if the missing adoption of AI tools for a small, medium enterprise brings the company, takes the company to a loss of competitiveness, share of market, and reduce opportunity of a new job, okay? What is very important, as I told before, is that artificial intelligence allows us to transform the data that are available. Every day more and more data is available because the new machinery we have seen, CNH, but also our machinery that we are producing small robots for vineyard, etc. They are collecting a lot of data, and what allows to transform this data in value is a tools based on artificial intelligence. The capability to select this data, to find the correlations, and to give us a guidance through a good practice for the cultivation. Here, okay, I don't know how was the target of the public, so I make a small example for, no, sorry, this is just to distinguish between AI and generative AI, okay, that is an important discrimination. AI is what we normally use for text analysis, the translator, classification, explanation and synthesis of documents, conversational agents, the chatbot, all these The generative AI is the next generation of AI, and is based on machine learning, and this technology allow to generate some new documents based on the training made before. The first is only a classification. Text recognition, this is A or B, and okay, AI say, okay, you have more probability that is the letter A, okay? The second one, once you have trained, you see, oh, okay, all these are image of nature. Create to me a new image of nature with a sunset and with many trees, okay? And is created a complete new image, okay? So this is very, very powerful in our experience, okay, for the coding. I don't know if you had this experience, but writing a code, you know, you have the concept of the code, but there are, let's say, 70% of the code is how to print something, how to, I mean, to complete the code correctly, grammarly corrected, and this is, you know, I was impressed because you write the first 3 lines of code, and the artificial intelligence understand what you are going to do, and they write, you know, 2 pages of code, and most of the time is exactly what you was going to do, okay? Sometimes not, but most of the time. So this speed up your work. So again, for what we normally use, the tools that we normally use is, for instance, to prepare marketing. Why these tools are more important for small, medium enterprise? Big enterprise have marketing people, marketing department who develop, you know, text, who develop advertising, who develop everything. A small enterprise, many times, you know, they are making a new exhibition in Korea, and they have to translate some leaflet, okay? Okay, so in a very short time they can make this, okay? So for agriculture, in our sector, for agriculture company, okay, these are the activity that you know, where artificial intelligence are having a very big important role, okay? Especially for agriculture and livestock management, you know. Today you can put a wearable sensor on your livestock, and getting the temperature of thousands of animals, and monitoring that, and checking how they if they are ill, and how you can cure them, okay? Okay, here is other application for AI. This is the new trend, the blockchain technology combined with artificial intelligence. Is not related to agriculture machine, but is related to the food managing, okay? It's very, very important to know exactly what you are eating, where is the source, and how is it treated, with the reliability of blockchain and controlled by many, many tools. So AI is a booster for our business, okay? Is a booster. and is a powerful tools in our hand to compete in a world that increase rapidly the complexity, okay? And for the people that don't approach this technology, the world will become very, very complicated and not going to manage. I would like to make some example that we made in our company, but we don't have time. Sorry. Thank you very much.
Thank you, Mr. Barbieri. Okay, sorry, just a service communication. While we are preparing the last presentation, just a couple of information to recall that you saw graphics about the trends and the increasing of the adoption of AI in agriculture. That slides come from the Osservatorio Smart Agri-Food from University of Milan, and they'll be presenting actually today at 2 p.m. in Italian, so be aware of that. And okay, so everything is set. I give the floor to Marco Bertogna, Hypert Lab and University of Modena Reggio Emilia. Real-time applications, that's real challenging stuff.
Thank you, Alessio. Thank you, everyone. Let me try to introduce a little bit what we do. I'm a full professor in the University of Modena. I'm also CEO and founder of a company called Hypert. And we try to bring essential practical autonomy to real vehicle, okay? So I'm trying to give you, entertaining you a little bit, a view of what are autonomous vehicle beyond GPS-guided systems, okay? The first 3 talks were very interesting about potential AI application, okay? Some of them are low TRL, okay, are demo, example, prototype. So we are trying to do that in practice, in reality, okay? Joining synergies with many, many different companies. That's our Hypert ecosystems. We are both a company and an academic lab. We are about 80, 90 people. And yeah, we try to essentially make the best use possible of next-gen embedded system of chip. So the next-gen high-performance computing platform ported on a square centimeter, like powering your embedded controller in your agricultural vehicle, logistic vehicle, or racing vehicle. What we do, essentially, is something of this kind, okay? This is the tip of the technology or technological iceberg, if you wish. So we are able to run even racing cars, okay, with no driver in it. So no driver, no remote driver, no physical driver, nothing. Everything is done with the sensors and with the embedded AI that you have inside the vehicle, okay? Why am I showing this? This is an agricultural conference, okay? This is racing. What does it has to do with it? So this is probably the most difficult part of it. So if you're able to run autonomous vehicle at very, very high speed, this guy is running at 280, 290 kilometers per hour in a non-structured environment, okay? We don't have reflector, we don't have even GPS, we have tunnels, we have reflections, we have many, many different complications. We have opponents, not here, but in other scenario, in other setting, we are able to run with other opponents running at 250, 260, and so on. So let's try to develop the technology for these complex settings and then port whatever is needed to practical applications, okay? There are so many problems you cannot imagine, okay? So one thing is having an autonomous tractor powered with a GPS, but what if GPS doesn't work, okay? What if you have something like that, okay? If you go in a vineyard, if you go in a forest, if you go close to a building, you can see here we are going close to a building and the GPS is deviating significantly, it's meters and meters. So how do you run your vehicle? What we do is properly using AI-based or classical control-based SLAM, perception, localization, fusion, and so on, and power everything on the smallest possible embedded system on chip, okay? So try to make real products with an affordable price without using too many expensive sensors, okay? And without requiring the vehicle, the autonomous vehicle, to cost more than the vehicle itself. So how can we do that? So I believe that we are trying to follow this global trend about autonomy, okay? Why are we hearing these days about autonomy and AI, okay? The main reason is, let's say, the deep learning revolution that the previous talks also touched upon. But let's say that most of this revolution have been powered by challenges, okay? We have Tesla, we have Google, we have Waymo, we have Uber working on autonomous vehicle, because back then in the 2000s, there were these DARPA challenges that essentially were trying to propose autonomous vehicle out to the research community. And from there, a lot of companies stemmed out, okay, that were able to show autonomous driving even in very, very complex environment. Let's say that these racing challenges are kind of the next step in this kind of technological challenges, okay? We took them and we are trying to, even despite the low funding that we have in Italy and in Europe, try to compete with the big giants there. This is a slide I like to show because it shows you what are the investments in this sector, okay? Not only agri, this is just focusing on urban, okay? But you can have similar slide on agri, on logistics, and so on. So these are the companies that drove the most miles out there, okay? You can see even where they come from, okay? I'm seeing here a lot of US flags, a lot of Chinese flags, but no EU flag, okay? No Italy, no Germany, no France, okay? Why is that? Because the investment are huge, okay? Prepare to understand. One thing is GPS driving. That's something easy, okay? It's already mature technology, but has a lot of problems, okay? Another thing is fully autonomous driving and make full use of DNN, neural networks, generative, you name it, okay? These companies are investing a lot of money, technology, people, workers. Luca before said the importance of upskilling, okay? The importance of having technology specialists on this kind of domains, okay? Europe is not prepared, okay? Is not prepared to that. We need significant more investment than what we do today. This is probably the best autonomous vehicle out there, okay? It is not Tesla, okay? Tesla is good, but is not able to run so-called level 4 yet, okay, despite what Elon Musk claims. This is a Waymo, so it's Google car, and you may notice that it's equipped with tons of sensors, okay? 13 cameras, many laser scanners, radar, ultrasound, you name it, okay? It's extremely, extremely expensive. It's estimated to be above 200,000 K just for sensory and electronics, okay? So that's not affordable, okay? That's not affordable, but it's working. It's working already in urban environment with careful and with, let's say, conservative planning solutions. And of course, this is completely changing the commercial world in automotive, as it will in the agri, as it will in logistics. It's gonna be a revolution. It's already being a revolution, okay? You can see that some of the players, this is automotive, are already spending a lot, investing a lot in the unitary price of a car. Almost 50% today is electronics, okay? Already today, before the electric revolution and before the autonomy revolution, okay? Most of the brands are still there, but some of them for advanced driving assistance. This is not autonomy, this is driving assistance, which is, let's say, the first step towards autonomy, and the cost, the unitary cost for each car are very, very expensive, are very, very significant. So what are the challenges? This is the challenge I presented a few weeks ago to our friends at CNH. So the consumer are not willing to pay a lot for autonomy, okay? Of course, you can replace the human labor, but then there are many, many factors that you need to take into account. So your autonomy kit should cost less than it does today, okay? So how can we do whatever the previous talk said with a reasonable and affordable price, okay? That's a problem. How do we do like long-term testing and validation? One thing is a demo. We have cars, we have 3 cars in our company. We are able to run you through Modena city with no driver, steering wheel, actuation, everything goes smoothly, okay? Is that a product? Not at all. How much do I need to make it a product? 100 times or 1,000 times more than what I spend until today, okay? Testing and validation is the elephant in the room here, okay? This is the most important thing to take into account. So do not believe demo that you see around, okay? A demo is nothing. If you do products, it should work on 1,000 different vehicles, on 100,000 different vehicles, 24 hours a day, for years, okay? We are not there. We are there only for specific operational design domain. Agriculture is one of them, okay? In agriculture, we have many, many mature products that we can do and we can use for this revolution. So restrict the operational design domain to reduce the safety and validation problem. There are many, many nice things that can be done here. I'm not going to repeat what you already know and also what the previous talk properly mentioned, okay? In agriculture, there are huge, huge opportunities. If you are a vehicle producer, if you're an engineering company, there are so many nice applications that you can try and do before other ones will do, okay? Not in Europe, but elsewhere likewise, and try to influence this kind of world. This is just one of the demos that we show here. We teamed up with an Italian company. This is a lawn mower. Okay, what's the new about it? I already saw an autonomous vehicle in agri domain. Yeah, but probably you didn't see something that works without GPS, okay? For instance, here we are in an agrivoltaic or in a photovoltaic field. GPS doesn't work properly, okay? You have reflection, you have interferences and so on. So what does your lawnmower do when it doesn't have the GPS, okay? Well, we designed this autonomous and precise localization kit based on inexpensive sensors that provide essentially what is called natural navigation. Natural navigation is what we use to navigate, okay? And this is already a demo, a prototype, and is becoming in the next month a product. Just as an example, okay? Localization is one aspect. You then have sensor fusion. You then have obstacle detection, forecasting, tracking. You have digital twin. You have remote control. There are so many difficulties and nice aspects in this autonomy challenge that requires big investment and big teams to develop, okay? It's not something that you do with 4 or 5 developers, okay? It's something that, I mean, the investment that you saw before are justified by that. Otherwise, you will keep having your GPS track, which may be enough or it may be not. These are other examples of vehicles that we did, okay, for just to try to anticipate what is the future, and I'm reaching the conclusion. Vehicle is not just moving stuff, it can be picking stuff, okay? This is something we did, it was for the defense domain, but what is above is not a weapon, it is a robotic arm, okay? So we are starting to mount robotic arm on tracked vehicle in order to complete also picking missions, placing missions, and so on, okay? This is just a demo, it is not a product, but we are working, we are increasing the TRL of this kind of application in order to do even more complex tasks, exploiting whatever the previous speaker told you about, okay? Embedded AI, so placing AI in your vehicle to do practical stuff. What is the take-home message? So, yeah, huge investment, complex ecosystem. Do not trust demo. One thing is a demo and the other thing is making commercial opportunities with a robust and safe stack and secure stack. Think about Cyber Resiliency Act and whatever will come in the year to come. Italy and EU needs to really move faster than we are. We are trying to do it, but we are a small reality. We are less than 100 people, okay? Way more investment are needed here, okay? So try to influence also the decision maker in putting more investment and more money in it. We need open innovation. Even academic has its own fault, okay? I'm a professor, but many, many colleagues, or even me before, do not have a clue about what a practical application is, okay? This dichotomy is detrimental to innovation, okay? This is something that we really, really should do in the future. We are in time. The last news is we are still in time, okay? All these huge companies have billion-dollar investment, but revenue close to zero, okay? So we are still early, okay? But clock is ticking, okay? Thank you very much.
Thank you, Professor Bertogna. I just would like to say, don't trust demo, but the ones that are outdoor here,
Oh, yeah.
you see in the AMA real area, you're gonna see live demonstration of agricultural robotics outside to this hall in between hall 37 and 35, happening in the morning, in the afternoon. Thank you to all the speakers for this night's presentations and suggestions about the new trends and the new, maybe, new visions of the future using AI. Now I give the floor to the next presentation, which is from a company exhibiting downstairs in this AIMA Digital called Kiwitron, still talking about artificial intelligence solutions. And the official FederUnacoma program will start again in the afternoon at 3 p.m. So don't forget the two events related to autonomy, cybersecurity, data analysis, and whatsoever. So thank you for being here. Thank you again to all the speakers.